Hi all the students, today here we are going to talk the topic motion from part 5 of your CBSE topic. Now here what we are going to talk in this topic is we are going to get some relations of equations from your graphical analysis method. Now equation of velocity time, equation of position time, equation of position velocity are the things we are going to talk in this particular video. Now the first thing which we are going to talk is that when we have a uniform acceleration, you can have a relation of velocity time which is v is equals to u plus at and distance time as v is equals to u plus ut plus half at square when acceleration is uniform. Again I am saying, so v square minus u square is equals to 2as. You can derive these equations by the graphical method. Now we are going to learn that in the form of a graph. Now you can see u is initial velocity, v is final velocity, a is acceleration, t is time, s is distance traveled over here. Now here equation for velocity time relation. Velocity time relation equation is v is equals to u plus at. Now here we are trying to get that by the graphical method, like velocity time which is a and b over here. Velocity is taken on y-axis, time is taken on x-axis. Now here from this particular graph we can get that BC is nothing but this one. BC you can find out just a minute, right? If you want to find out BC, right, now here we can find BC in this format, like BC is nothing but, if you want, you can take it as V, and OA you can take it as U. Now here BC is nothing but BD plus CD. Now CD is nothing but equal to OA. Now we can equate it like this, like BD plus OA, substituting BC as V and OA as U, you can get that V is equals to BD plus U. Now from there what happens over here, if you want to find BD, BD is equals to V minus U. So BD is equals to V minus U, this is very important. Now that is nothing but BD is equals to change in velocity. Change in velocity is nothing but, we can write it as acceleration is equals to change in velocity by time. So from there change in velocity is nothing but BD, BD by time is nothing but AD. So AD is nothing but OC which is T. So substitute that as BD by AD which is nothing but BD by OC, and that is equals to A is equals to V minus U by T. Now V minus U by T, so from there you can get V minus U is equals to, if this T goes that side you are going to get AT. So this is how you find out the relationship, like V is equals to U plus AT. Now let us get into the next relation. Next relation over here is nothing but, we have S is equals to ut plus half at square. In this S is equals to ut plus half at square relation, we will try to find it out by this graph method again. Now in this method what you will be learning is, you can learn this as you take a area of a trapezium, because velocity time area is going to give you distance. So let us bring out that equation from this concept. Now S is equals to area of OABC, and which is a trapezium, which is nothing but area of a rectangle, which is, this is the rectangle over here, and another rectangle, another one you have a triangle over here. Now what happens, this is half base into height. What is this one? Length into breadth. Now what happens over here is, you can find out both the areas. Like if you try to find the area of a rectangle, you will be finding out OA into OC plus half AD into BD. Now when you can find out, like you substitute that OA is nothing but, we already know that it is U, and we know that this thing over here is nothing but V. So we will substitute that OA into OC plus half AD into BD, which is nothing but OA is equals to U, OC is equals to AD which is T, and BD is equals to, we already have discussed that BD is going to be V minus U in the previous slide itself. Now what you will be doing is, from this you can easily find out BD is equals to V minus U, so that is nothing but equal to AT from the previous slide. Now what happens over here, you substitute that S is equals to, what do you say, S is equals to OA is nothing but U, we know that OA is U, and OC is nothing but T, OC is nothing but T, and we also know that half AD is nothing but AD is nothing but T, so I substituted this AD with T, and BD is nothing but B, and D is nothing but what? BD is nothing but again AT, because BD is V minus U, which is nothing but AT. So substitute that AT in the place of BD, right? Now what you are going to get? S is equals to UT plus half T into T is T square into A. So this is the relationship between the distance and time. You can call it as a position time relation by the graphical method. So I hope this is helpful. Let us get into the next relation. The next relation over here which we are going to talk is this one, equation of position velocity relation. Now equation of position velocity relation, if you want to speak, you are going to get it like this. Now here the same graph again you are going to take. The graph over here is a constant graph which is going to denote you an acceleration of a uniform acceleration and a constant increase in the speed. Now what you are trying to find out? Position velocity relationship, which is nothing but v square minus u square is equals to 2as, or someone will be pronouncing it as 2as is equals to v square minus u square. Now to find out that, you have to find the area, because this is a distance relation, right? Now area of a trapezium, if you are trying to find out OABC, this is the area of a trapezium. Again we have area of a trapezium is nothing but OA plus BC, OA plus BC, OA plus BC, which you are going to get this side into OC, which is nothing but this side, which is T. And what happens if you try to find out the area of a trapezium in the numerator? OA plus BC into OC by 2, which is half into this half is going to give you by 2 over here. Now when you try to find out that, substituting that OA as U, you can substitute this OA as U and BC as V. Now you try to substitute it and OC as T. Now you just substitute those values. OA is U, BC is V, OC is T by 2. So S is equals to, you have V plus U into T. Now what you will be getting? V plus U into T by 2. So this is your relation. Now what happens? From velocity time relation, we can get V plus U into T. You will be getting T value, you just send that to that side, and T is equals to V minus U by A. Now what happens over here? S is equals to, you substitute that T value as V minus U by A, V minus U by A. Now here V plus U into V minus U by A is nothing but S. So it is nothing but 2as. Finally if you send this 2a that side, you are going to get 2as is equals to V square minus U square. Now I hope this is helpful, and you might be getting the relationship over here clearly. For V square minus U square is equals to, V square minus U square is equals to 2as relationship is clear for you all. Now I hope this is fine for today, and let us meet in the next part. Until then, bye.